So now this is an array. Now let's talk about NumPy. Let's talk more specifically about this format. What is this type? NumPy dot nd array. The nd indicates that this is a structure that can contain multiple dimensions. It can have n dimensions. So this is what the nd array stands for. Our specific instance has only one single dimension. Now, for example, let's take this marks as an example. So let's say marks dot shape. When I try to do this, you will be able to see that this is a one dimension. Excuse me. The shape confirms that this array has only one dimension, which contains probably how many elements? 1, 2, 3, 4, 5, 6, 7. 7 elements. So there are 7 elements in the original list, and that is what we are trying to get it. And here is the one. Let's say if we want to manipulate or just handle the first element of the entire list or array in this case. So marks, where are you? First element. When I try to send it, you're trying to get the first element of it. So this is marks. Oh, this marks is different, and the mark that I am talking about is different. So this is something somewhere here. This is mark. So the first element is what we got it. Let's say um, we want to handle more numerical operations. Now let's say, for example, we need to know what is the mean of this marks or scores of a particular school, not school, class, obviously. So we can just directly type in called marks dot mean. As a result, we get whatever the mean score of marks is. So as a result, we get whatever the mean score it is. Now this is one of the essential element of utilizing numerical or mathematical operations using NumPy. Till now we have dealt with single dimension arrays. Now let's deal with 2D arrays. What are 2D arrays? Essentially what we are trying to do in our intermediate, we might have seen something like, hey, there is a matrix. Where you paint? So probably in our intermediate we might have seen something called. So now let's deal with 2D arrays. So probably in our intermediate we might have studied what are matrices. Let's say, for example, there is a matrix called A, and this contains 1 0 0 1. Remember, this was called identity matrix. Any which way. Now what is this? So this is a 2 cross 2 matrix. What does it say? There are 2 rows and there are 2 columns. Now in our case, in the one which we have just discussed, so oops, sorry. So in our case, there was a matrix which was stating that this is, hey, there is only one element, and I don't think there is any other column as well. So it was just this. But now that we just have witnessed, uh, now that we are talking about 2D matrices, so let's try to create one which essentially looks like our identity matrix. There is one. So how do we do it? So we already have a data. Let's just explore our what are we having at our dispenses. So there is marks. Marks has something around 1 2 3 4 5 6 7 elements. Now I want to create something called study hours. How does study hours? Probably 10. 10 is the study hours. Let's make it decimal. So somebody might have 11 study hours. Somebody might be a genius. 9. Somebody might be studying only for 5 hours, and probably somebody might be studying for 16 hours. Did we cover everything? No. 16, let's say, 15.3. Okay, so this one we might have solved 1, 2, 3, 4, 5, 6, 7, 7 hours. Got it. Now, for any array, it should be of, if you are devoting to, or if you are trying to make a two-dimensional array, you must look into its shape. Those, both of these should be identical. I mean, it should contain same elements, same number of elements. Now, if we look in what is the shape of it, oh, I think it is definitely a single list, but let's create now. Let's create a 2D array which contains study hours and the marks. So student data, let's call this as student data, but this student data contains np, no, f dot. So remember how we just configured our numpy as f. So f dot array, it's not a very good fashion to use f and all this stuff. We can use other things. Now this is study hours, this is one, and there is some another one which we have made called marks. Now I want to look into how this data looks like. Student data. Now if you see this, so it definitely looks like a 2D array. Why do we have to do guessworks? Let's go directly and check, hey, is this a student data or not? Dot shape. So when you try to do a shape, it gives you the shape of it. Now what does it try to say? The student data contains two elements, each of which is an array containing 7 elements. Should I just repeat again? Here, the student data is an array that contains two elements. What are those two elements? The study hours and the marks. And each of which is an array. So each of this thing is an array which contains 7 elements in them. So essentially I'm just breaking it down, but yeah. So now if I try to, what do I, how do I try to access or navigate or just focus on one particular, let's say for example I want to focus on this 5. So if I have to deal with that, how do I go it? So how do I navigate this particular thing? So to the student data, which is essentially in the 0th column, so 0th row, which is the starting row, what is the column? 1 0 1 2 3, and when you try to do that, you will get 5. This is what I'm trying to look into, and this is how you get it. Now, hey, how did you get to 0 and 3? So any array or any sort of thing in computer science, they start with 0 and goes like that. What is this? Whole numbers, that's it. Computers use whole numbers, they can only understand whole numbers. So that is where 0 is the starting element of it. Now you don't use 1, your wish. If you can use it, but just that you'll not get to the desired location. So let's say for example if I'm doing 1, what do you think I'm going to get? So it checks in for the element which is 1, so first row, and it's not the first row, it's the second row, but yeah, in index wise it is first 0 1, so it is second row, and what is this? 3, third column. So in our case it is exactly fourth, 1 2 3 4, so it should return us something called 38.